Lesson 6, motion in 2 dimension. We are still on projectile motion. This is now the part 2 of our video lecture series. For this video, we are to answer some problem examples or example problems relating to projectile motion. Let's have our number 1 problem here, whereas a cannonball is launched at a velocity of 20 meters per second in a direction making an angle of 25 degrees upward with the horizontal. First question natin is that what is the maximum height reached by the object? Same as the last time, the most effective way to attack a problem like this is first to illustrate. So according to our story here, we have a cannon, something like that. Then it releases a cannonball. Let's change our ink so it's visible. Here, at an angle of 25 degrees upward. So this one. At a velocity of 20 meters per second. So from there, magmo-move yan dyan. And then our first question stated is that what is the maximum height? Which means at this certain point here, yan, bago siya bumagsak, gaano kataas ang ating H max or Y max na kayang abutin ng cannonball na ito given the following variables. Okay? So, let's write down our given according to our story. We have here, of course, the velocity. We have already written it down. Maximum height is not there. We have the angle of 25 degrees. And of course, gravity is negative 9.8 meters per second as per our story. Okay. So, we have illustrated, we have written down our given. What is now the formula we are to use? First, you have to remember that we are now talking about projectile motion. According to our previous video, we are to treat the x dimension and the y dimension separately. Which means that before you try to look at your formulas here, you are to determine what dimension would you work on. So, according to our question here, what is the maximum heights? And of course, obviously, when we talk about height, we talk about the y dimension, which means we are to focus on our formula here on the top right corner. So, ito ang ating pagpo-focusan. Okay. First question is that we are searching for the maximum height. Let's see if what formula is applicable for that. First formula, let's see. Obviously, we won't be able to use this since there's no y in this formula. On the second formula, it's possible because we have here yf. And let's analyze. Do we have yi? Of course, that will be the starting point of this cannon. That should be 0 meters. Siyempre, kung nandito siya nanggaling, bago siya umangat, mag-start siya sa 0 meters. We have our initial velocity and that is 20 meters per second. Time it took for that to happen, I don't think that's given. How about gravity? Of course, is given. And then we don't have time. Okay, so possibly natin magamit yung second equation, but let's try to look at our third equation if it's more applicable. Okay? So for our third equation here, we are searching for y final. So pwede yun dito lumabas because of this variable here. However, do we have our final velocity? Wala. Do we have our initial velocity? Yes, but we don't have our final velocity, so this is still missing. Okay, so we are now left with the dilemma on between equation 2 and equation 3, what is the most appropriate? Okay, so for equation number 2, we have to search first for the time before we can find the y final. Meanwhile, in equation number 3, we have to search for the final velocity for us to search for the y final. Okay? Both of them can be completed by using, I think, the first formula. Okay, the first formula. Here. Okay. So, I think the most feasible thing to do is to search first for time here, and then we plug it here. Okay? Search for time here, and then we plug it here. Why? Kasi the second formula is already searching for y final, right? So sa third formula kasi, we have to still isolate that, and that would still give us another step. Of course, doon tayo sa mapapadali yung buhay natin, which is to just substitute. Okay, so that will be our strategy. Let me repeat. Our strategy would be, we are to search for y final using the second formula plus 1/2 g t squared. So this is our final formula in searching for the maximum height. Pareho lang yan. But we have to search first for our time. And for us to search for our time, we need to use equation number 1. That is VFY is equal to VIY plus gravity multiplied by time. Okay? So do we have our final velocity? Not yet, but we'll try to analyze what's our final velocity in a while. Do we have our initial velocity? Yes. Do we have our gravity? Yes. And we are searching for time, so that makes sense. Okay. Same as the last time, we'll now try to look if there are any values here that we can equate to 0. Okay. Analyzing our final velocity here, diba? If an object here moves at a certain height, there will be a point that it will stop. Kindly remember that. Why? Kasi diba, if you, for example, you throw here a basketball and then you throw it upward, before it starts moving downward, diba? Before it starts moving downward, there will be an momentarily situation here where it will stop before it starts accelerating downward due to gravity. Which means that at the maximum height, our velocity, our final velocity should be 0. Again, let me repeat why. Kasi diba, when you throw something upward, hanggang i-consume niya yung kanyang acceleration dahil pinukol mo, but there will come a moment whereas it will now be pulled downwards because of gravity. And at that moment, the velocity would be 0. So this, for short, should be 0. Okay? So that would be 0. Which means our formula would be zero is equal to VIY plus GT. Okay. So what we want to do now is that we want to isolate G. We want to isolate T sa katabi niyang G. Okay, that's what we want to do. For us to do that, I'm going to transfer VIY to the other side of the equation, making it a negative VIY is equal to GT. Isolating T, divide both sides by G, and then this will be cancelled out. Our final formula now is T is equal to negative VIY. However, you have to take a moment here. If you can recall, in our vectors, Let me erase this one. If you can recall in our vectors, this v here, the velocity of 20 meters, it's moving at this direction. That's the velocity of 20 meters per second. However, we are now just focusing on the y dimension, which means that this v here is actually a resultant vector. Okay? A resultant vector. Now, this wouldn't be a problem anymore because we already know how to search for the component of a vector. And what component of a vector do we need? Remember that if v is already a resultant vector, magkakaroon siya ng vector on the x dimension, we call that vx, and it's going to have a vector in the y dimension. We're going to call that viy. Okay, this would be vix and this would be viy. Now, our angle as given here in our story is 25 degrees. Right? So this should be 25 degrees. Now, according to our SOHCAHTOA, what part of the triangle is our VIY? Okay? So if this is our angle, our VIY is at the opposite side. Right? Which means that we have to use sine theta. Which means that going back to our formula here at the top, VIY is actually VI sine theta according to our analysis here at this side. Right? And that's over G. That is now our formula in searching for the time in the air. Okay, let's compute for that. Let me erase this one again. Okay, and if we try to compute T, let me continue over here. T is equal to negative VI sine theta over G. Let's write down our values. Our negative VIY, our negative VI is the velocity given, which is 20 meters. So that would be negative 20 sine the degree, which is 25 degrees here. So that's negative 20 sine 25 degree over the acceleration due to gravity, and that is negative 9.8. Again, I won't write the units, so it will be cleaner for us. Let us compute that. Please get your calculators. Negative 20 sine 25 degrees over negative 9.8. We're going to have 0.862. For short, our time in the air is 0.86 second. This is now our time. It took our cannonball to go from this point up to the maximum height. Okay, up to the maximum height. Now, how do we now search for our maximum height? We now have our time. We are to simply plug it here on our equation. But first, let's search if there are any variables that should be zero here, just like what we have done on the previous one. YF should not be zero because that's actually what we're trying to search for. So, hindi pwede. YI is the initial position of the cannonball, which should be zero. Diba dito siya mag-start sa loob? And we can take that as zero. Okay? So our VI should not be zero because that's the initial velocity. But again, that should be the initial velocity on the y-axis because we're talking about the maximum height, and the maximum height is at y dimension. Plus 1/2 G can't be zero, that's gravity, and then we still have time. So our final formula is YF is equal to VI sine theta. Again, where did we get our sine theta here? Because we are to talk about VIY. And our VIY is negative VI sine, is VI sine theta multiplied by time plus 1/2 gravity times squared. So this is now our final formula in trying to search for our maximum height or our YF. Okay, let's write down. YF is equal to VI sine theta, that is 20 sine 25 degrees multiplied by our time, which is 0.86, plus 1/2 negative 9.8. That's gravity. Gravity. Still multiplied by our time. That is 0.86 squared. Okay. Let's plug that in our calculator. 20 sine 25 degrees multiplied by 0.86 plus 1/2 or 0.5, pwede rin, negative 9.8, 0.86 squared. Okay, the answer is 3.649. Okay, so that it's safe to say that our final height is 3.64 meters, since we are searching for height that should be in meters. So that's how you do it. How to search for the maximum height. Let us repeat or have a recap on what we have done. First, you read the problem. A cannonball is launched at a velocity of 20 meters per second in a direction making an angle of 25 degrees upward with the horizontal. So for short, when we say about with the horizontal, this is our horizontal here, and then the cannonball is up at an angle of 25 degrees. Okay, so what is the maximum height reached by the object? When we talk about maximum height, we are talking about something in the y dimension. That's why we have used equations in terms of y. We write down our given, that's Vi, which is the initial velocity, 20 meters per second. Kindly take note that this is a resultant vector. And if you are talking about something in the y dimension, you need to search first for its component vector in the y-axis. Our gravity is negative 9.8 meters per second. We are searching for the maximum height. What is our strategy? Upon looking at our equation here, we have found out that the best formula is this second formula. However, we're missing our t here, which is our time. It took the ball from here to that point. Okay, so we're missing that. To search that one, what we did is that we analyzed if we can search for the time in the air using equation number 1, and it made sense that we need to search first for the time in the air. We plug it here and we solve for our YF. That's what we have done. Again, you are only to do this if wala na kayong no choice, if wala na kayong ibang formula that you have to use. That's why you need to use other formula before you try to answer your final solution. Okay, in doing that, we write down our first formula here. We equate anything that can be equated to 0 to simplify our formula, and we have found out that VFY, which is the height, which is the velocity at the highest point, should be 0, because anything that you throw up, it will eventually or momentarily stops before it tries to accelerate downward. That's why it's 0. Okay, VIY, GT, we are want to isolate T. So what we have done is I move VIY to the other side, making it negative, divide both sides by G to isolate T. This is now our final equation to search the time it took the ball, the cannonball, from the ground up to its maximum height. The answer for that is 0.86 seconds. We plug it here. But before that, we try to analyze what part here can we equate to 0, and that is y initial. Why? Kasi the cannonball started at the horizontal, which means that nandito muna siya sa lapag before it tries to be propelled at that part there. Okay, so that is why I0. And also take note that VIY is actually the initial velocity in the y-axis. That's why we still need to write down our sine theta or our angle here. And 1 half GT, we write down our variables here. Our final answer is 3.64 meters as our y final. Do you have any questions? Okay, so we'll now proceed with our next problem here. The next question is that what is the total flight time between launch and touching the ground of the object? Now, remember that total flight time is also time in the air. Okay? Kasi it's the total flight time, meaning from when the cannon has been fired up to it reaches the ground. So bago siya huminto sa ground. So that's what we mean when we say time in the air or the total flight time. Okay, so let's write it down. Let's draw it again here, which is ng mas maayos. This is the cannonball. We won't draw the cannon anymore. And it moves from that point to that point. Okay, so what is the time it took or time in the air for that cannonball? Okay, so we have few strategies here that we can do. First is to analyze. If you're going to look at this one, yung sinolve natin actually sa letter A, that's the time from this point up to this point, right? Let's call that T1. Okay, so the time it took the ball from the ground up to the top is T1. And we also have here another half. We'll call that T2. And if you're going to analyze this situation here, we can actually just double the time it took the cannonball from this point up to the maximum height and from the maximum height up to the ground. Bakit pwede natin gawin yon? First, the velocity will equalize each other. Plus, we have the same acceleration due to gravity. For short, time in the air can also be equal to 2 T1. This one. Which means the doubling lang natin T1, then we're going to have time in the air. So let's write it down. 2. And that is 0.86. So we write it down here, 0.86. 2 multiplied by 0.86. You plug that in your calculator. And that should be 1.72 seconds. Okay? So that's the first strategy in searching for the time in the air for our situation here. Okay. What is the other situation? The other situation is that we are to use our formula. Okay? That is, we'll write it here. The formula, which is the first formula here, right? So that's VFY is equal to VIY plus GT. And again, our final would be 0. Again, we are talking about the time in the air, which means we're talking about the y dimension. For short, if you're going to analyze, it doesn't matter kung nagka-curve siyang ganon. Again, in a projectile motion, the x and y are separate dimensions. Ibig sabihin, there will be a time na aangat siya, and then there will be a time na bababa siya. Right? And yung time ng pag-angat niya, we can call that as time 1/2, and the other one would be time another 1/2, which means that time in the air is also equal to 2 time 1/2. Okay? 2 time 1/2. Going back to this formula here, katulad ng ginawa natin kanina, let's just transfer VIY into the other side of the equation, make it negative VIY is equal to GT, and divide both sides by G. Then your T now will be T is equal to VIY. Again, VIY is also VI sine theta over G. So, ibig sabihin daw, yung T is actually equal to VI sine theta over G, which is what we have proven here a while ago. Diba? Yun yung na-prove natin dito kanina. However, when we talk about time in the air, according to our premise here, the time in the air is actually 2t1/2. And if this formula here is our t1/2, we just have to multiply this by 2 according to this premise here. So that's the same. Okay? Which means we can just plug in our value. Time 1/2 is equal to 2. VI sine theta, our VI is again 20. Sine the angle, which is 25 degrees, over our G, which is negative 9.8. Sorry, this should be negative. So this should be also negative. You multiply that, you're going to have an answer still of 1.72 seconds. So pareho lang. So you can either, so this won't be time in the air anymore. I know, this won't be time 1/2. This should be time in the air because it's already multiplied by 2. So this is your final answer. Okay? Recap. You're asked to answer to find out the total flight time or the time in the air. We have two strategy. First is the conceptual, which is the theoretical. Kumbaga ni-logic lang natin na if the 1/2 here took 0.86 seconds, we just multiply that by 2. So you're going to have 1.72 seconds. The other one is that we have, actually we just have proven this first one, but through the use of our formula here, which is VFY is equal to VIY plus GT, what we did is that we searched for the, we have understood that 1/2 here, the 1/2 time ng pag-angat niya is actually twice, when we talk about time in the air, is actually twice the time of the air. Kaya nilagay natin dito is 2t1/2, right? And then, what is now the formula for t? The formula for t can be derived by using this one, right? So that would be VIY. Let me just cancel this para mas simple. T is equal to VIY G. And we know that VIY is actually VI sine theta. And according to our premise here, this t here, this t1/2 here, is actually twice for us to be able to search for the time in the air. And that's what we did. After that, we plug in our value here, and our final answer is 1.72, same as the last idea. So you may either use any of the following. So that's how you search for the maximum height and the total flight time. For our third question, but again, these are all connected problem set, kaya A, B, C, D. But we still have the same situation here, whereas, let's analyze. We still have a cannonball launched at a velocity of 20 meters per second in the direction of 25 degrees upward with the horizontal. Our question now is, what is the horizontal range? Okay, what is the horizontal range? So what do we mean when we say horizontal range? So horizontal range would simply, let's illustrate so we can visualize. If the cannonball is fired from that point up to this point, what is the range here? Meaning, what is our XF? Gaano kasaan yung inabot niya? Okay? So let's look. We are now talking about an object in the X dimension. Okay? Which means that we are now to focus our attention on the formula for X dimension. Let's look at our formula here. Equation number 1, obviously we can use that, there's no X there. Equation number 2, it search for XF directly. So, mas posibleng ito ang ating gagamitin. Meron tayong XF. Do we have an XI? Yes, our XI is actually the starting position here. And that should be 0, which means this is 0. VIX, do we have a VIX? Yes. If you have here a VI, that's the resultant vector. Katulad ng ginawa natin kanina sa VIY, we can isolate that using SOHCAHTOA. So that's possible. Do we have time? Yes, and that is the time in the air, which we have solved on letter B. So we have time in the air. That's 1.72 seconds. How about our acceleration? Do we have an acceleration for this problem? According to our story here, a cannonball is launched at a velocity of 20 meters per second. So there's no acceleration given. Okay, there's no acceleration given. And when I say acceleration given, that's acceleration in the x dimension. Now, there is an acceleration in the y dimension, and that is gravity. However, remember that as we have discussed a while ago in our concept, you cannot use the values, for example, acceleration that is acting on the y dimension on the x dimension. So, hindi siya pwede. Which means that although this is the same story, our acceleration on the x dimension is 0. Which means this would be 0 also. Okay? So, our formula now can be XF is equal to VIXT, which is fairly simple already. Let's look at our third formula here. Do we have our final velocity? We haven't searched for the final velocity dito. Do we have an initial? Yes. Acceleration would be 0. However, if this is 0, it will also cancel out the delta x there. So, that won't be possible. So, our final formula is XF is equal to VIXT. So, fairly simple. Now, the only concern here is that we need to convert VIX into its resultant vector component. And to do that, let's draw here our cannonball with an initial velocity of 20 meters per second. Okay. So, from here, same as the last time, we can conclude na meron siyang y dimension, we call that, x dimension, we call that VIX. At meron din siyang y dimension, we call that VIY. And the angle for that would be here, which is 25 degrees. Okay, we are now trying to search for VIX, which means that in terms of this triangle here, it's at the adjacent side. And according to SOHCAHTOA, if the adjacent side, we are to use Ka, which means VIX is VI cosine theta multiplied by the time in the air, which means kung gaano kalayo yung nangyari na yan. Okay, so let's write it down here. VI is 20 meters. That's our initial velocity. Cosine 25 degrees. That's the angle here, which is 25 degrees. Multiplied by the time in the air, and kanina na-search na natin yan, the answer for that is 1.72. And just multiply that, plug in that in your calculator. Cosine 25 multiplied by 1.72. You're going to have 31.176. So that's 31.18 meters since we're searching for XF. So that is now our maximum range or our final position. Okay. Now, let's now proceed with our fourth problem. What is the magnitude of the velocity of the object just before it hits the ground? Okay, just before it hits the ground. Meaning, let's illustrate that. If this is your cannonball and it's been fired at a projectile, okay, if it started with a velocity, an initial velocity of 20 meters per second, ang question natin ngayon is, etong part na to, bago siyang bumagsak dyan, ano daw ang kanyang velocity? So that's our question. Okay? So, if we are searching for the magnitude of the velocity just before it hit the ground, it also means that we are actually searching for the final velocity in terms of a resultant vector. Okay, and you already know how to search for a resultant vector, right? To search for the resultant vector, you need to use the Pythagorean theorem by writing down your Vx squared plus Vy squared. However, the question now, what is our Vx squared and what is our Vi squared? Our Vy squared. Okay, let's write it down. Our Vx is actually, we have done it a lot of time. Our Vx is actually Vi cosine theta. Diba? That's what we have defined here. Our Vx is actually Vi cosine theta. Okay. And our Vy, according to this one, okay, our Vy, according to our y dimension formula, our Vy here would be this one. Is this one. Why? Because that's the final velocity is equal to the initial velocity, sorry, walang F, plus GT. So these are the formula. Sir, bakit po walang T dito sa ating VFX? Sorry, this should be VFX. Sir, bakit po walang T? Why? Because if we're going to look at our formula here, okay, so this is our formula in searching for the velocity on the x-axis. And upon our story, there's no acceleration, right? We have defined it a while ago. If the acceleration here is 0, that will always be 0. We are left with Vf is equal to Vi. Meaning, kung ano yung sinimulang velocity niya in the x-axis, that would still be the velocity on the final velocity on the x-axis. Would that make sense? Yes. Kasi nga, the only acceleration that is happening on our projectile is the acceleration due to gravity. And gravity affects velocity only on the y-axis, not on the x-axis. Which means that on our x-axis, our acceleration is actually constant. And a constant acceleration, meaning it's a zero acceleration, so that would be 0 here. You're left with Vf is equal to Vi. And our Vi is in terms of the x dimension. That's why we have Vi cosine theta. Okay. However, on the VFY, that's not the case. We have gravity there, so we won't be able to cancel that out. Okay, so this is now our two formula. Let's write down. Vi is 20 cosine 25 degrees. Meanwhile, VFY is 20 sine 25 degrees plus, that's negative 9.8 multiplied by our time in the air, that's 1.72. Okay, and you put that in your calculator, the answer here would be 20 cosine 25, 18.126. So that is 18.13 meters per second for our VFX. Meanwhile, for our VFY, that's going to be, let's put that in our calculator. 20 sine 25 plus negative 9.8 multiplied by 1.72. The answer there is negative 8.40 kasi it's 8.403. So the answer here is negative 8.40 meters per second. Okay, so this is now your VFX. This is now your VFY. We know how to search for the resultant. Let me just clean this part here. Okay, so that would be the square root of Vxx, that's 18.13, squared plus VFY is actually negative 8.4t. Pwede na natin hindi ilagay yung negative. So that's 8.4t squared. Let's put that in our calculator. 18.13 squared plus 8.40 squared. The answer for that is 19.98. 19.98 meters per second. That's rounded off to 20 meters per second as our final velocity, which is 20 meters per second. And if you are going to observe, okay, if you're going to observe, our initial velocity is actually 20 meters per second. And our final velocity is still 20 meters per second. Would that make sense? Yes. Okay? Because the velocity, kung gaano siya umandar dito, paano siya lumabas, it will also gain that as it goes down. So, it just makes sense that they are the same. Okay, recap. Recap for letter C. Again, we are searching for the horizontal range, that is XF. Upon looking at our formula here, we have seen that XF we should use the second formula, but XI should be 0 and acceleration should be 0. We are left with XF is equal to VIXT. This is our formula here. And we know that our VIX should also be our VI cosine theta according to the resultant vector. And our T here should be air. And air, we have already searched for that a while ago. Previously, we have the answer for that is 1.72. We plug it here. Answer is 31.18 meters. For letter D, we are now searching for the magnitude of the velocity of the object just before it hits the ground. Which means that if it started at a velocity here, which is 20 meters per second, gaano ang kanyang bilis bago siya tumama sa lupa? Okay, kasi when we say that it already hits the ground, it will be 0. Okay, so to do that, we know that if we are searching for the magnitude of the final velocity, it means that we are searching for the resultant velocity of our final situation. And the formula for that is the Pythagorean theorem, if you can recall, our vector, component, and resultants. And for us to do that, we need to have our VXF and VYF. How do we search for our VXF? Still, we go to our formula. And according to our formula here, searching for the x dimension VF, our formula is equal to VI plus AT. However, just like what we have said a while ago, there's no acceleration on the x-axis, only on the y-axis, which means that our acceleration would be 0 here. We are left off with our formula VF is equal to VI, and we write it down here. However, since we're talking about something on the x-axis, VI should be VI cosine theta. We plug our value, our final answer is 18.13. Meanwhile, when we try to search for our VFY, our formula would still be the first one, but this time we have acceleration. And that acceleration is the acceleration due to gravity. You plug in your value here, your answer is negative 8.40 meters per second. You write it down in your Pythagorean theorem. The final answer is 20 meters per second. Any question?